All right, welcome in everybody. I hope you're having a wonderful day. I'm recording this just mere hours before our class, and I'm going to make it a nice, quick one. And it's going to be a nice, quick, easy module because I know a lot of you are just, cramming through a lot of work, like trying to finish up, catch up, do all that stuff. And I want to give you that opportunity. So you're going to love it. Tonight there will be no quiz. It's only 3 sections, and then you're done. And if you complete it all before the Zoom tonight, don't feel like you have to attend the Zoom. Like, why would you? Unless you just really want to hear me talk and see me do this every 3 seconds. But anyway, so let's just run through what we already know. Oh, first and foremost, and I'll tell this in the class, like grades are not updated yet because people are doing so much work. It's almost like I'd have to update it by the hour, but they will be updated by the end of the night. Anyway, so if we go to discussion boards, so we're talking about volcanoes this week. It's a pretty cool topic. It's one of those cool things that is one of those observable phenomena that we've been focusing on. So we've been talking about, we started with plate tectonics, which, in and of itself is not really observable, but through things like earthquakes and volcanoes, stuff that we can experience, we can sort of deconstruct some of these phenomena and figure out why they happen. So this discussion board here is very similar to the last one. There's no video you got to watch. I just want you to make that connection between plate tectonics and volcanoes. And so you use this link to the USGS, which is really easy for the second question. But the first one is, how are volcanoes related to plate tectonics? Well, if you hop back to the plate tectonics one, you'll see that as the subduction occurs, you have this partial melting of the crust, which makes its way up through the other crust, the crust above it, and eventually will oftentimes be erupted as lava onto the surface of the Earth in the form of a volcano. Now, much like we had different types of faults, we have different types of volcanoes. And this USGS site, which I will hop on out to, will tell you all of them in there. We got the cinder cones, we got the shield volcanoes, we got the composite ones, and we will also talk about them during this lecture. So I'm not going to take up too much time with that. That's your discussion board. Make sure you hammer that out. A lot of people are already getting this done and out of the way, and I think that's just fantastic. So if we hop to our homepage here, we're going to scroll all the way to the bottom, and you'll see your week 13 module. And I should have started with that because I'm kind of going backwards. So this is where this is going to be, what I'm doing right now. The PowerPoint that I'm about to go over is sitting right here. And then lastly, let's take a quick peek at our CK12. Keep in mind, this is week 13. We have next week and the week after, and we are done. So all of the CK12 stuff has to be done before I turn in grades, which will be that following week. I'm giving you that extra week up to May 6th to get everything done. But May 6th is like that deadline that cannot be moved. Okay, cool. So hopping on into our class here, going on into our assignments, and we will see. We have volcanoes right here waiting for us. We used to have like these really long deadlines here, but now they're getting a little bit shorter because of the lack of time that we have. So there you go. Just 3 sections: volcanoes that plate boundaries, and volcanic hotspots, because hotspots are really cool. They do not occur at plate boundaries, so they're not really too much involved there. But places like Hawaii, that's a hotspot. And we'll talk about like Kilauea and whatnot. And, you have other hotspots like the Yellowstone caldera is a hotspot. And it's pretty cool. But it's all the same stuff that we've done before. You're going to do your adaptive practice for each of the sections, and then you don't have a quiz. So it should be a pretty quick and easy one. But use the articles, use the study aids, use the real world examples to enhance that knowledge along with this lecture that I'm about to do. So let me hop on back. Let me hop on into the lecture with the PowerPoint. Here we go. And so this is a nice little PowerPoint. I enjoy this one. So let me, come on, let me project it. Let's go full screen. There we go. All righty. So first off, we always want to define, what is a volcano? We know that Vulcan was the god of fire. And then we talked about that when we also talked about Plutonic rocks, where Pluto was the god of the underworld. Well, now we get the god of fire, which makes sense. These volcanoes erupt in very, hot, fiery messes, if you will. So volcanoes are often, but not always, cone-shaped, but they could take other shapes as well. And they are strictly formed when molten, we can call it sticky rock, called magma. That's when it's underneath the surface, forces its way through a crack in the Earth's crust. So like with earthquakes, there was like a break in the Earth's crust, and that's where movement occurred. Well, with volcanoes, they still need some sort of conduit, some sort of like pathway to get to the surface. and that's what the volcano provides. So some sort of crack in the earth, the magma will rise up, it comes out over the earth, and then it's lava. So the melted rock that spills out of the crater on top of the volcano is called lava. So we have another word there, the crater, which is like that indentation, that bowl part of the volcano. And so the lava destroys essentially anything in its path because it's very, very hot. Now, that being said, it will, it's not going to like instantly melt like rock that it touches. You know, it'll heat it up. It will contact metamorphose some rocks. All right, we're pulling in some stuff we learned before, but it doesn't necessarily, just obliterate those rocks. It sort of forms paths, and it'll flow, along with almost like water. Water takes the path of least resistance. So will volcanoes and lava. The volcano won't; it'll stay there, but the lava will move. So where do they occur? Pretty much everywhere. We have a high concentration of them at plate boundaries, but there's also hotspot volcanoes, and there's some that form from fissures in the earth where lava comes up. But so most volcanoes are formed on land. There are undersea volcanoes, like with Iceland or the mid-ocean ridges. Those are undersea volcanoes. So some of these volcanoes can emerge from the water because they get very high, not the recreational high, but they will start at the bottom of the ocean and then just continue to erupt, and they build, and eventually they break the surface of the water and they create new islands. This is how the Hawaiian Islands are formed. This is how Sturtsey, which is an island close to Iceland, was formed. And so they can sort of rise up, help create new landforms, and if they're active enough, they will continue to produce. So there you go. That's a volcanic eruption. So we can see there, like obviously there's been a release of pressure. That's why that magma is shooting up, becoming lava as it reaches the Earth's surface, and then it flows with the least resistant path until it flows no more, until it cools and stops. And then sometimes you'll get like a crust that forms on top, and then the lava keeps going. And then when the lava's gone, that crust, that little sort of shell remains, and you have like lava tubes and lava caves. It's really neat. But why does it erupt? So a volcano erupts when the magma and gases find a way to escape. So there's not only like the molten rock, but there's gases mixed up in here as well. And so with the gases being mixed up, along with the very hot magma that will make its way to the surface due to density differences, once it reaches a point where there's such little pressure above it, it will kaboom, erupt. Or, it may be so less viscous. We have this term viscous, which means like sticky. If it's not very sticky, and that's dependent on like chemistry and also like the dissolved gases, it can flow just like a river, like the one currently going on in Iceland, and like how we see in Hawaii. They can flow and not just necessarily be super eruptive. So when it gets to the surface, though, usually we'll have some sort of a eruption through what's called a vent. So the vent is the little pathway that it has to come to the surface. So you may have heard like, this volcano is active or dormant or extinct, and it's important for us to differentiate between those ones. So an active volcano is one that is sort of alive. It erupts often or regularly, or they can monitor below it to see that it still has activity going on beneath the surface. So we also have this term called dormant. So dormant doesn't necessarily mean it's not going to erupt anymore. It just means it hasn't erupted for a really long time, but there's still that possibility. So we call that dormant, which is kind of like sleeping. It's pretty cute, right? Cute little sleeping volcano, wakes up, goes nuts, blows hot rock everywhere, and damages a lot of stuff. Kind of like us in the morning, right? We wake us up and we're not happy, and we just start destroying things, and hopefully not, but who knows? So we also have extinct volcanoes, but in order to qualify as an extinct volcano, it has to be sort of dormant or non-eruptive for 100,000 years. So that's a long time. So once it hits that mark, it is considered to be extinct. So one type we have is a shield volcano, and the name here is pretty suggestive of what it's like. It's like this smooth sort of mound, this not very steep little shield, if you will. I mean, that's what we call a shield volcano. So they are made mostly of fluid lava flow. So this is very basalt type lava. Um, Meaning that it almost flows like a river. Like we're going to talk about volcanoes that have a lot of dissolved gases and a lot of like sticky mineral composition, and those are our more explosive ones. But shield volcanoes are the calmest of all the eruption types, and they also are the largest volcanoes that are on Earth. But they're not very steep, so it's kind of deceptive. Like if you go out to Sima Dome, or if you go out to even Kilauea. Like these are long expanses of this gentle sloping volcano that almost resembles like the back of a turtle, a turtle shell. So the Hawaiian Islands are composed of chains of shield volcanoes. So those are the perfect example. You can check those out, and they're really cool when they flow. And it's really neat to see like the fluidity of it, like how much it can just stream along. And so we can see this is how it kind of forms. But we have, a shield volcano, which is this big, sort of like gently sloping, but very expansive volcano. And what it is, we have this magma chamber down here, and as it makes its way to the surface, it doesn't have a lot of dissolved gases, doesn't have a lot of sticky magma, if you will, and so it just sort of flows out over everything. Now, we compare that with a stratovolcano, which is also called a composite volcano. So these volcanoes are typically tens of miles across, so they're still pretty big, and 10,000 or more feet in height. So they are very tall. They have a very steep slope. And this says moderately steep sides, but I'm sorry, these are steep sides, and they're very sort of like textbook looking, and we'll get to those in just a second. So they're called strato or composite volcanoes because they consist of layers of solid lava flows mixed with layers of sand or gravel like volcanic rock called cinders or volcanic ash. If you have like scoria or like decorative rock in your front yard, and it's like that sort of like that dark orangish but like light, and it has like little holes in it the whole way through, that's scoria, which is a type of volcanic rock that's kind of like a cinder. And when you hit them together, you hear almost like a clink rather than like a thud you would with like more dense rocks. And so that's why they're called composite, because there's more than one thing in there. There is the lava flows, but there's also the sand and the gravel and the volcanic ash and the rock that comes with it. So Mount Vesuvius, which is one that destroyed Pompeii, and Mount St. Helens that went off in Washington in the 80s or 80, one of those two. But anyway, so that one, when it went off, it had a huge, massively powerful eruption. And part of the deadly parts of these ones is there's hot ash that falls down. I always got to emphasize the H on that one. But then also there's what are called lahars, which are like volcanic mud flows that we'll get to when we talk about the hazards. So this is Mount Vesuvius, seen in Naples, Italy. If you want to click on that movie, it's a pretty cool one, but you can see how different it is from the shield volcanoes. So these are very, wide across, but also very sort of steep. You have that classic volcano shape here. And we have a couple other ones. We have a Mount St. Helens, we have Mount Rainier, and then if we, I went a little bit too quickly there. And you can see here part of the problem when these erupt, you have this, ash being blown out, and then you have it just running down the sides. There's also like hot projectile rocks called lava bombs that get shot out. And so that's one of the things that makes them very, very dangerous. For the cinder cone volcanoes, these are small, cute little volcanoes. You can see them if you drive up the 395. If you get to around what's called Coso Junction, you'll see a bunch of them. They're really cool. They're usually, not very wide and not very tall. They're almost like mini composite ones, and they can get to be about 1,000 feet high. So not super tall, but still, neat on the landscape to see. And so they say, they have grainy cinders and almost no lava. It's just sort of like this eruption of material, not necessarily lava that flows out, but you have those like cinders, those like the scoria that I was telling you before. If you drive out on the 40, you get to like close like to Ludlow out there, and you'll pass by like huge lava flows on the right hand side that are mainly this type of volcano, that are cinder cones that create very economic type rocks because people use them in their landscaping and such. So they have very steep sides. You can climb these out in, like I said, if you drive on the 40, you're going to come across Amboy crater. Amboy crater is a cinder cone volcano. you can climb right up to the top and you can look right down into the crater, and it's actually really, really neat. So this is one of the ones we're talking about. This is out by Coso Junction. And so you can see they're almost just like mini little cute fun size volcanoes. But we don't see like that typical like big lava flow. You just have like that grainy material that will be erupted out. And so that's the Coso volcanic field there. You can see like each one of these little lumps here, not the mountains in the back, but each of these little lumps are cinder cone volcanoes. So they're very common. We got a ton of them out here in California. You can go and explore them. The Amboy one has lava tubes you can go through. They're really fun place to be. Not when it's erupting though. So we have 3 different types of eruption patterns. And we can call them levels, if you will. But the patterns that we typically see, if it's easy for the gases to escape, they don't get stuck within the chemistry that is the magma, you'll have this very gentle flow. The lava can move pretty fast. That's one of the dangers because it gets very, very runny. And so it can move faster than other types of lavas. Now, you also have where gas can build up. And you can have like lumps of preformed rock within the magma, and then sometimes the gases can't escape. And then, so when that happens, sometimes it'll shoot these pieces of material from inside the volcano out in what are called bombs. And you can kind of see these. Sometimes they have like really neat little football shapes because they sort of get aerodynamically carved as they fly through the air. But one of the big things about this is that you begin to get this thick and sticky lava. And when that happens, it can't easily flow to the surface. So then pressure builds up and it builds up and it builds up. And then kaboom. So this is the fiercest type of eruption. You have a magma that's very high in silica. So if you remember, that's like continental style crust. But you get the gases that are trapped inside there. And it's like shaking up a soda can and then hand it to someone and be like, open this on up. Kaboom. Luckily, it's just soda and not, hot ash and magma going into their face. But yeah, this literally blew the side off of Mount St. Helens. Like Mount St. Helens was, let's see if I can get this going to be a good thing. So it was like a mountain like this, and then lava started to form, and it created like a bubble on the side, and then that side just literally blew off. And so let's hop back and talk about Mount Kilauea in Hawaii, because it is the most active volcano on Earth. It's been erupting since 1983. So I have never lived without Kilauea erupting. Like I was born in 84, and it's been erupting since 83. That's pretty cool. And another thing that we get that's pretty cool from volcanoes is what's called pumice stone. Now, some people may know this. If you're good at exfoliating and keeping that smooth skin, you know what a pumice stone is. But this is essentially like volcanic foam. And so it's a very light rock. It floats on water, usually light in color. And it has like these bunch of little tiny bubbles where gases would be. And if you have that, you have a pumice stone. And they're very good and sort of gentle for exfoliating, smoothing out the skin. I recommend one for like the heels and the elbows. You always want to stay nice and smooth. You don't want to have like that rough skin there. But if you do, doesn't matter. Love you anyway. So the word volcano we've talked about before, so we don't need to go over that very much. But just from Vulcan, and he was the Roman god of fire. So it makes sense. So we want to talk about a couple terms, then we'll wrap on up. So we have a lava bomb, which is a lump of rock that gets thrown out in an eruption, just sort of like rocketed out. These could be small, these can be large. It could be like being hit with like a little pebble, or it could be like having a building dumped on you. I shouldn't say building, maybe like a VW bug, something like that. Like a small car, one of those little smart cars, like the Fiats. That could be a lava bomb. So the crater, that's the deep hollow sort of bowl impression or depression at the top of the volcano. And then we have the crust, which is the top layer of the earth. So this is what our lava is going to flow out over, but it's also what gets driven back down into the earth at subduction zones that then once again gets recycled back out as lava. So it's just the circle of rock here. Not the circle of light, the circle of rock. It sounds like a musical I need to start writing, so I need to remember that. Now, the eruption is just the release. So when you see this stuff in CK12, the eruption is just the release of the gases, the magma and the rock from the volcano. The lava is, once it is on the surface, that's the hot material, And magma is when it's down below. And then molten, when you hear that term molten, just think melted. Molten, melted. Kind of an easy little connection there. And then the vent is just a crack, not necessarily on the side of the volcano, but just a certain place where magma can escape, where gases can escape. And so any sort of crack that allows that to happen, we call it a vent. And you will see that in your CK12. So some of the hazards that we have with volcanoes is one of them is called a lahar. So lahar, so we saw some of those pictures of volcanoes. They were on like these mountains with like big old snow packs around them. Well, when the volcano erupts, it melts that snow pretty darn quick. It's now you have this muddy, hot, like there's volcanic ash mixed up in there, and it just flows like a giant mud flow that's super heated and just wipes out anything in its path. And then we also have what's called the pyroclastic flow. So if we break that word down, pyro means fire, clastic means rock. So these are very hot rocks that just rocket down the sides of these volcanoes. And they level trees, they sort of torch everything in their way, and these travel at hundreds of miles an hour. So this is a dangerous portion of pyroclastic flow. You ain't outrunning this one. No way, no how. And that's that. Those are the things you'll see in the CK12. That was your little bit of knowledge. I look forward to seeing you all tonight, and we'll discuss more and have an excellent week, excellent weekend. And you are so close to the end. Super proud of the work you're doing. Just keep it up.